Hello everyone, welcome to today's video. And today we're going to cover some limits when it comes to polynomials and fractions, as well as limits that have to do with square roots and fractions as well. So we're going to go over 4 problems today. The first 2 will involve some polynomials, and then the last 2 will involve square roots. I will leave some timestamps down below, and you can go to whichever problem you think you need more help with. And without further ado, let's get straight into this one. So right now we have the limit as x approaches 1 of x squared minus 1 over x minus 1. The number one thing that you want to take into consideration when you're doing these types of problems is the number one process that you'll be doing is factoring. And that is across the board whenever you're dealing with fractions and limits. The first strategy that you always want to implement before you even try anything is to plug in the limit into the function. And if it gives you a number, that's what you will use, right? And you don't have to do anything else. However, in this case, you'll notice that if you plug in 1 in for the function, in the denominator, 1 minus 1 will be 0, it'll be undefined. So obviously we're stuck there because we can't use that. The next step will be factoring. I can already notice that x squared minus 1 is a difference of squares, which means I can factor it down as such. So this would be the same thing as saying the limit as x approaches 1 of x plus 1 and x minus 1, because once you distribute them out, you're going to get x squared minus 1, because the difference is squares, so the middle cancels. That'll be all over x minus 1. Here, I hope that you'll see what is kind of happening. So now, the easiest next step to do is to cancel this x minus 1 that was given as issues in the denominator up here. So these cancel, so now we're just left with the limit as x approaches 1 of x plus 1. Now we can go back and check whether we can plug in this number in. In this case, we can do it, which is 1 plus 1, which is equal to 2. And that will be our answer for this particular limit. Now I'm going to move on to the next problem. And it'll be a little bit more difficult, but nothing too crazy. And I'll see you guys in a second. Alright, here is the next problem that we have to deal with. And the first thing that I want to note again is that the numerator is t squared minus 9 is a difference of squares. But before we do anything, just to double check, I want to plug in this -3 in here in the denominator to see whether we can just get a random answer, right? In this case though, when you plug this in, you'll notice that you're going to get 0 again, and you can plug it in if you want to double check me. But you're going to get a 0 in the denominator, therefore we can't just plug in the limit right away. So again, the name of the game here is factoring, right? So we're going to have to figure out a way to factor the numerator or the denominator in order to cancel something out. But I know the numerator can easily factor to t plus 3 and t minus 3 because it's the difference of squares. But the denominator doesn't even have those factors yet, right? So I have to both factor the numerator and the denominator in order to get a common factor that I can cancel out. Okay, so the top is pretty easy to factor. Let's just work with the bottom. So I'm just going to work and expand this bottom, right? The first thing that you notice is that this a factor on the a squared plus on the polynomial is not 1. Normally when it's 1, we can easily do the factor of factors of 3 that add up to 7, right? But since this is not 1, we're going to have to deal with a different strategy. You can do whichever way you like. I like to factor by grouping, and this is how you basically do it. So you multiply a times c, which is this first term a and the last term c. So 3 times 2 is 6. Now I get factors of 6 that can go into 2 and 3, right? The easiest one that I can think of is 2 and 3 because it can go into those 2 right away. So then I can rewrite my equation, and this middle term will be replaced by these 2 factors. So I'm going to coin this 2 to this 2t squared, right, because it can go right into these 2. And then I'm going to do the plus 3t here, and then add in the plus 3. So what we do here is we group them really quickly, and now I like to get common factors out of these parentheses. The first common factor here, it'll be this 2t, and I'm going to be left with this t plus 1. Now I do common factor here. The common factor is 3. And I'm going to be left with t plus 1 as well. Now, if you notice when you're doing factoring by grouping, if the parentheses are the same, And your two factors are this 2t plus 3 and t plus 1, right? So my factor here and t plus 1. So this 2t squared plus 7t plus 3 can be written as 2t plus 3 and t plus 1. However, let me write the function again though. Let me write the limit that we're trying to figure out. If the limit as t approaches negative 3 of, I'm going to factor the numerator right away, so it's t plus 3 and t minus 3, and then that'll be over 2t plus 3 over t plus 1, or times t plus 1. Here, the issue is that none of these are common factors that I can cancel out. None of these match up, so I can't just slash anything out. So did we do something wrong? Like, what happened, right? In this particular case, nothing wrong happened, but we can try something else because there are more factors than just 3 and 2 that can go into this 2t squared plus 7t plus 3, right? Okay, so I'm gonna backtrack here and I'm gonna go back and try, let's say 6 and 1. I'm gonna try 1, I'm gonna connect to 2, and then 6, right? Here, in this type of problem, I'm gonna do the same thing and I'm gonna rewrite this middle term. But I'm gonna choose 1 to go to 2t and 6 to go to 3. So 1 will be plus t, and then now will be plus 6t here, and I'm gonna group these ones. And now that I have the function here rewritten, now that I've rewritten the middle parts, so these would be the factors that I'm gonna be looking for now. The common factor here is gonna be just t, which I'm gonna be left with 2t plus 1. And the common factor here is going to be 3, and I'm gonna be left with 2t plus 1. Now you'll notice that the parentheses are the same, so my two factors can be written as t plus 3 and 2t plus 1. So I'm going to go ahead and rewrite the whole limit really quickly. Negative 3, and then the numerator I'm going to factor it out. So it's t plus 3, and then t minus 3. And the denominator will be now a t plus 3 and a 2t plus 1. Now hopefully you'll see that this t plus 3 is a common factor, and I can easily cancel that out. So I'll just be left with this limit of t approaches negative 3 of t minus 3 over 2t plus 1. So now let's just plug in this negative 3 in. In the numerator, I'm going to end up with a negative 6. In the denominator, this negative 3 times 2 will be a negative 6 plus 1 will be a negative 5, which is the same as saying 6 over 5. So that would be the answer to the limit as t approaches negative 3 of t squared minus 9 over 2t squared plus 7t plus 3. Okay, that was pretty quick. Hopefully I can condense it down easy enough for you guys to understand how this come about. Again, the name of the game is factoring, and sometimes when it comes factoring by grouping, maybe the common issue is you're choosing the wrong factors here to do the grouping with. It doesn't happen too often, but you'll see it sometimes happen, especially when these odd numbers in the polynomial. So try that in your next problem. Maybe that's where you're going to get stuck on. But now we're going to move on to the square root problem. So I'll be right back. All right, so here is the next problem that we have set up, and that'll be the limit as h approaches 0 of the square root of 9 plus h minus 3 over h. Square roots are a little bit different than polynomials in that sometimes the first thing that you want to try in polynomials is obviously doing factoring. But before that, before we even do anything, let's plug in h equals 0. Right? Obviously, there's going to be a 0 in the denominator. It'll be undefined. So in terms of square roots, what you're going to want to do, the most common thing I see with problems, you're going to have to rationalize either the numerator or the denominator. And I'll go over what it is in a little bit. But in this case, what I'm going to see is I'm going to try and rationalize this numerator here just so that I can get rid of the square root. Basically, what rationalizing means is you want to get rid of that square root so that it's easier for you to start canceling things out. So what we do here is we're going to simply multiply by the conjugate. Or in other words, we're going to multiply by the square root of 9 plus h plus 3 over the square root of 9 plus h plus 3. Notice that the only thing I'm doing is I'm multiplying the same thing, but I changed the sign because I'm trying to make it a perfect square. Basically so that the inside or the middle of that multiplication, when you FOIL it, will cancel out, and all I'm left with is these two factors multiplied by each other and these two multiplied by each other. So when we do this, this is going to go on to be 0. Here, now I'm going to have 9 plus h on the square root times the square root of 9 plus h. So the same thing multiplied by each other. The square roots are going to cancel. So I'm going to end up with 9 plus h. And the middle is going to cancel, right? Since this is a perfect square right here. And I am going to multiply just the ends. So negative 3 times 3 would be a negative 9. And then the denominator, I'm going to have square root of 9 plus h plus 3, right? Because that is multiplied as well. Normally, what I would tell you and give advice is when you're multiplying something by denominator here, keep it just separated. So keep these in parentheses and don't distribute it. It doesn't always work that way, but sometimes it's easier to just keep it like this because then you'll see something really quickly when it comes to canceling things out. So the first thing now I'm going to go over combining like terms. We have this 9 minus 9, which is going to give me 0. Right, so these are going to cancel out. And now the only thing I'm left with is h over h in the numerator. So hopefully you'll see that now what we can do is cancel those h's out since we kept it factored. Because if you were to distribute this h out, you might have not seen it right away, but now that it's here, you can just cancel these out. And all I'm left with is the limit as h approaches 0 of 1 over this square root of 9 plus h plus 3. So now I can go ahead and plug in my 0, right? So 9 plus 0 is going to be 9. Square root of 9 is 3. 3 plus 3 is 6. So my answer is 1 over 6 for this problem. That was a fairly simple one when it comes to rationalizing. And if you need more practice rationalizing, I would do more problems like that. It's just multiplying whatever the numerator or the denominator is by the same thing, but you're just flipping that sign so that the middle cancels, and all you have to do is multiply the first terms and the last terms together. Now we're going to go into a more difficult problem involving square roots, and it's not only going to involve rationalizing, we're going to have to do more steps as well. So I'll be right back. All right, so here's the setup for the next problem, and it'll be the limit as t approaches 0 of 1 over t times the square root of 1 plus t minus 1 over t. Okay, so normally, like I said, we would plug in 0 in, but hopefully you clearly see that it's going to give me zeros in the denominator, so we can't do that. Here, instead of the first step being rationalizing, you'll see that there isn't really something that we can multiply each term to rationalize it because there isn't that additive or subtractive factor in either the numerator or the denominator. It's just single factors alone. But the number one other common thing that I see, or a strategy, is that whenever you see fractions that don't have the common denominator, the first thing to do is get that common denominator so you can combine those fractions into one single fraction, and then you can start working at it and try and get common factors out and try and cancel things out or rationalize the numerator or denominator. So in this case, again, the second strategy would be get a common denominator. Like I said, these are not written in a specific order or step. These are just some of the common strategies when it comes to these problems that you'll probably be utilizing. Okay, so I want to get a common denominator here between this 1 over t times square root of 1 plus t and 1 over t. The thing, I'm going to look at this 1 over t, and I can notice right away that the only thing missing here is this square root of 1 plus t factor. So all I'm going to do is multiply this fraction by square root of 1 plus t over square root of 1 plus t, right? So t approaches 0 of 1 over t times the square root of 1 plus t minus 1 over t times square root of 1 plus t over the square root of 1 plus t. And then what we can do here is distribute it out and rewrite the whole function, or right now that we have multiplied it by this factor, we can rewrite the function into just one single fraction instead of two different fractions. So we can see here that now both of the denominators are going to have the same factor of t times the square root of 1 plus t. So the denominator is just going to be t times the square root of 1 plus t, right? The numerator, we have this 1, we have this minus 1 times the square root of 1 plus t. So it would be just 1 minus the square root of 1 plus t. All right, so now we have this whole equation written in one fraction, this whole function written in one fraction. Now, hopefully you'll see that here we have the same, almost the same pattern as we had in the last problem, this 1 minus something under the square root. So that should give you a hint that now the next step is to rationalize that numerator. So what we do again is multiply by the conjugate. So multiply it by this 1 plus square root of 1 plus t over 1 plus square root of 1 plus t. And now what we're going to get is we're just going to multiply the outsides together. So 1 times 1 is 1. Now the insides, right, is square root of 1 plus t times itself. We'll cancel out the square root. So you're getting minus 1 plus t. Now don't forget these parentheses when you're doing these multiplications, especially when there's a negative sign or a minus sign before it, because this negative has to be distributed in to the whole parenthesis. If you don't do that or forget to do that, you might get the same number as your answer, but it won't be the correct sign. So just keep an eye out for that. And then I'll have it over t square root of 1 plus t over 1 plus square root of 1 plus t. Okay, so now I'm going to distribute this negative in, and I'm going to get negative 1 and negative t. So then I'll get 1 minus 1, so they'll cancel out. And then I'm going to get left with a negative t. So this will be the same as saying the limit approaches 0 will be negative t over t square root. Now actually, I'll give you another hint here. Since I know that the t is in the numerator, I know that I have to cancel something out. And the only thing I have left is this t. So I have to cancel somehow a t from this function, right? So what I can do is I can distribute everything in, but I know I'm going to have to cancel this t. So I'm only going to distribute this square root of 1 plus t into both sides instead of the t itself, because I know I need to cancel it. So what it'll look like, it'll be t times, and I'm going to distribute just the square root of 1 plus t, and I'm going to get the square root of 1 plus t plus, when I get the same thing times itself, the square root cancels, so it'd be the square root plus just 1 plus t, right, for the denominator. All I did was FOIL this out. Now I can easily cancel this t out. Now I'm going to go over to my next whiteboard, and we're going to rewrite this. So the limit as t approaches 0. Now it's going to be negative 1 in the numerator, so we have that negative still. In the denominator, we're just going to be left with this parentheses here, which will be just the square root of 1 plus t plus 1 plus t. Now we can go ahead and see if we can plug in the 0 and it'll work out. So here we have plug in the 0, and we're going to have just the square root of 1, which is 1. And then here we're going to have 0, it'll just be 1, so 1 plus 1. Therefore our answer is going to be negative 1 over 2. So that'll be the end of that problem. I did go a little bit fast. I skipped a little bit of the algebra, and I'm hoping that you can somewhat understand that. And if you don't, that is totally fine. Please write down in the comments down below which step do you think I need to go over, maybe slow it down a little bit. So hopefully you guys learned something, and if you did, please leave it down in the comments. Like, subscribe to the channel. It has been your boy Night Brisk, and I will see you guys in the next video.